Hey everyone, welcome back to Singularity today. I'm Atom Infinity, and today we're diving into the fascinating world of artificial intelligence research. We'll be exploring some of the most cutting-edge advancements in fields like computer vision, language modeling, and robotics. These researchers are pushing the boundaries of what's possible with AI, developing powerful tools and techniques that could revolutionize our lives in countless ways. So grab a cup of coffee, get comfy, and let's explore these groundbreaking publications together. In the research titled Lexicon 3D, Probing Visual Foundation Models for Complex 3D Scene Understanding, the researchers delve into the world of 3D scene understanding. They explore different ways to represent and analyze complex 3D scenes, just like we try to understand the world around us by looking at it. The research compares different computer vision models, including image-based models, video-based models, and even models specifically designed for 3D data. They tested these models on various tasks like understanding relationships between objects, identifying objects in a scene, segmenting a scene into different parts, and aligning different views of a scene. The researchers found that different models excel at different tasks, which is like having tools for different jobs. For example, models trained on videos were good at recognizing objects, while models designed for 3D data excelled in tasks related to shapes and geometry. This research provides insights into which models are best suited for different 3D scene understanding tasks and challenges some common assumptions about these models. These findings can be used to improve 3D scene understanding technology, leading to advancements in applications like virtual reality, autonomous driving, and robotics. Imagine a robot that can navigate a room and understand its surroundings just like we do. This research is a step towards making such scenarios possible. In the research titled Wildvice, Open Source Visualizer for Million-Scale Chat Logs in the Wild, the authors present a powerful tool called Wildvice. Imagine you have a massive amount of conversation data from real-world chatbots, like the kind you see on social media or customer service platforms. Analyzing all of that data manually would be incredibly time-consuming and practically impossible. That's where Wildvice comes in. It allows researchers to explore and visualize these large data sets in a quick and efficient way. They can search for specific keywords, analyze topic trends, and even identify patterns in how users interact with different chatbots. Wildvice helps them make sense of this vast data, uncovering insights that would be hidden otherwise. The authors demonstrate its usefulness in several case studies, such as understanding how people misuse chatbots or comparing how conversations evolve across different data sets. The best part is that Wildvice is open source and extendable, meaning others can use and improve it for various research purposes. This research could have a significant impact on chatbot development and design, allowing creators to better understand user behavior and build more engaging and effective conversational AI systems. In the research titled ELM-C, Assessing Contextual Integrity Norms in Language Models, the authors explore the issue of large language models, ELMs, inadvertently encoding societal preferences and norms during their training process. This is problematic because as ELMs become more integrated into our lives, we need to ensure that their values align with our own. The researchers point out that these encoded norms can vary depending on factors like the training data, model design, and how the model is optimized. They also highlight the challenge of prompt sensitivity, where even slight changes in how you ask a question can lead to vastly different responses making it difficult to assess what an elm truly believes. To address this, the researchers developed LMC, an open-source framework for measuring the privacy norms encoded in ELMs. LMC utilizes a method called contextual integrity-based factorial vignette methodology, which examines the ELM's responses across different scenarios. To mitigate prompt sensitivity, they developed a multi-prompt assessment methodology that focuses on the prompts that consistently produce similar responses. The study then uses LMC to evaluate various ELMs using real-world examples from areas like Internet of Things, IoT, and the Children's Online Privacy Protection Act (COPPA). They also explore how factors like model size, design choices, and training methods affect the encoded norms. This research is important because it provides a way to understand the values encoded in ELMs. This understanding is crucial as ELMs become increasingly influential in our lives. Imagine a chatbot that gives biased advice based on its encoded norms, or a social media algorithm that promotes harmful content because of its biases. LMC can help us identify these issues and ensure that ELMs are developed and used responsibly. It can also help developers create models that better reflect the values of society. In the research titled Planning in Natural Language Improves LM Search for Code Generation, the authors explore the challenge of generating diverse and correct code solutions using large language models, LLMs. They observed that traditional search methods, where ELMs repeatedly sample code, often produce similar but incorrect solutions, leading to inefficient search. To overcome this, they propose Plan-Search, a novel search algorithm that leverages natural language planning. Plan-Search generates a diverse set of descriptions about the problem in natural language, then uses these descriptions to create plans for solving it. This approach allows Plan-Search to explore a wider range of potential solutions, leading to significantly better results compared to standard search methods. The research shows that Plan-Search, combined with the Claude 3.5 Sonnet language model, achieves state-of-the-art performance on a challenging code generation benchmark. They also found that the diversity of generated ideas is a key factor in predicting the success of search methods. This research has potential implications for improving the effectiveness of ELMs in code generation tasks, particularly in fields like software development and automated programming. Imagine having a language model that can not only generate code, but also reason about and plan the solution in natural language, ultimately leading to more robust and accurate code generation. In the research titled A Different Level Text Protection Mechanism with Differential Privacy, the authors explore a new way to protect sensitive information within text. They use a powerful language model called BERT to identify words that are more or less important within a text. This allows them to apply different levels of protection to different words, ensuring that the most important words remain recognizable, while the less important ones are obscured. The research highlights the importance of adapting the protection level to the importance of the word, as this impacts the overall usefulness of the text. The conclusion is that this approach, when applied to long texts, provides a more effective way to protect sensitive information while still maintaining the integrity and meaning of the text. This research has the potential to improve data privacy in various applications, such as medical records, financial reports, and confidential communications. Imagine a system where only the essential information in a medical record is protected, while less sensitive details are still visible. This method could be used to protect personal information in various contexts, ensuring privacy without compromising the essential content. In the research titled View Invariant Policy Learning via Zero-Shot Novel View Synthesis, the authors explore how to teach robots to perform tasks regardless of the camera angle they are looking from. Think of it as teaching a robot to pick up a block, but it needs to do it from different perspectives, like from above, below, or the side. The research leverages a technique called novel view synthesis, which basically allows a computer to imagine what an object looks like from different viewpoints using only one picture. This technique is then used to create a data augmentation technique called VISTA, which helps train robots to be more adaptable to different camera viewpoints. The research shows that robots trained with VISTA perform better than those trained without it, demonstrating that VISTA is a promising approach for making robots more robust and adaptable to real-world conditions. In the research titled Trace C's Trustworthy Reasoning for Contrastive Explanations in Course Scheduling Problems, the authors present a new system that combines the power of symbolic reasoning, which uses logic and rules, with the flexibility of large language models (LLMs). This system is designed to answer contrastive questions related to course scheduling, like why is this particular course schedule better than another one? Or what would happen if we change this constraint? The system uses SAT-solving techniques to translate scheduling rules into a logical format and generate explanations. These explanations are then refined into natural language sentences by an LLM, making them easier to understand for humans. The research highlights that this combination of symbolic reasoning and LLMs has the potential to create explainable AI agents that can not only provide solutions, but also clearly explain their reasoning behind those solutions. This can be incredibly useful in making AI systems more transparent and trustworthy. Imagine a student using this system to understand why they were assigned a specific course schedule, or a teacher using it to explain why certain classes are offered at certain times. This research paves the way for AI systems that can be more collaborative and understandable, leading to better decision-making in various fields that involve scheduling, from education to logistics. In the research titled A Method to Benchmark High-Dimensional Process Drift Detection, the authors tackle the challenge of detecting changes in manufacturing processes using machine learning. Think of it like trying to spot a change in a complex recipe with lots of ingredients. The research introduces a way to create realistic synthetic data that mimics real-world process data, allowing researchers to test different machine learning methods for detecting these changes. They also introduce a new way to measure how well these methods work, called temporal area under the curve. The research then compares popular machine learning techniques on this synthetic data to see which ones are most effective. This research can help manufacturers develop better monitoring systems to identify problems early on, which could ultimately lead to more efficient production and improved product quality. For example, it could help catch small changes in a manufacturing process that might otherwise lead to product defects, saving time and money. In the research titled Limited but Consistent Gains in Adversarial Robustness, by co-training object recognition models with human, each researchers explored whether aligning computer vision models with human brain activity models with human brain activity, or EE, can improve their resilience to adversarial attacks. These attacks are sneaky ways to trick computer vision models into making mistakes, like showing them slightly modified images that they misinterpret. The researchers found that by training computer vision models to predict human age responses to images, they did observe some improvement in the model's ability to withstand these attacks. However, the improvement was relatively small, but consistently observed across different model setups. This suggests that using human brain activity as a guide might be a promising way to make computer vision models more reliable and less susceptible to manipulation. The research opens the door to further investigations with larger and more diverse datasets, potentially leading to stronger defenses against adversarial attacks. This could be crucial for applications where reliable computer vision is critical, such as self-driving cars or medical image analysis. In the research titled Multimodal Laryngoscopic Video Analysis for Assisted Diagnosis of Vocal Cord Paralysis, the authors introduce a system called MASL Multimodal Analyzing System for Laryngoscope that combines audio and video data to automatically analyze laryngeal video stroboscopic videos for diagnosing vocal cord paralysis. MASL does this by extracting key segments and metrics from the videos. Imagine a system that can automatically find important parts of a video and analyze it for signs of vocal cord paralysis. That's what MASL does. The system is able to detect and segment the glottis, the space between the vocal cords, and then analyze the movement of the vocal cords, which helps identify if there is any paralysis. The research validated the system's ability to provide reliable metrics for diagnosis by conducting experiments on public and real-world datasets. This research can have a significant impact on the diagnosis of vocal cord paralysis, as it can provide a more objective and efficient way to assess patient videos, potentially leading to faster and more accurate diagnosis. MASL could be used in hospitals and clinics to assist physicians in diagnosing vocal cord paralysis. Imagine it as a tool to help doctors make better and faster decisions about patient care. This can improve the quality of life for patients with vocal cord paralysis. All right, folks, that's a wrap on today's dive into the cutting-edge world of AI research. Even though this whole video is brought to you by a bunch of ones and zeros, I hope you found it insightful and maybe even a little bit entertaining. Who needs a human to make a video anyway, right? Anyways, don't forget to give this video a thumbs up if you enjoyed it, and subscribe to Singularity today for more AI adventures. And if you have any questions or thoughts, leave them down in the comments. Don't forget to check out the research papers yourself and get your own brain going. They're all linked down below. Until next time, keep your brain sharp and remember, the singularity is coming. Maybe not today, but it's coming. See you later.